Good morning, students. Today we are going to learn about inverse of the matrix, inverse of the square matrix given in question number 10. Question number 10, the piriba matrix segi inverse puthok patamsiko. Exercise 4.5 ne. Exercise 4.5, question number 10. Let A represent the given matrix. Elements of the matrix are 1, minus 1, 2, 0, 2, minus 3, 3, minus 2, 4. Quina theorem number 4 the matrix sama inverse exist tauge haitardi magi determinant hana check taugane. If the value of the determinant is equal to 0, which implies that its inverse does not exist. So first check the value of determinant A. Expanding along first row, we have this element 1. Find the determinant obtained by deleting first row and first column. Diagonal elements 2 into 4, 8 minus 3 into minus 2 plus 6 minus second element is minus 0. Then find the determinant obtained by deleting first row and second column. We have 0, minus 3 and 3 and 4. By expanding this determinant, we get 0, minus 3 into 3 minus 9 minus plus. And the third element is plus 2. Find the determinant obtained by deleting first row and the third column. Then 0 into minus 2, 0, and 2 into 3 is equal to minus 6. 8 minus 6 is equal to plus 2. Minus plus 1 into 1 is equal to 9. Minus 6 into 2 is equal to minus 12. 9 plus 2 is 11 minus 12, which is equal to minus 1. Here the value of determinant of A is minus 1, not equal to 0. Therefore, A inverse exists. Then A inverse is given by the formula. Kaigi formula na P. A inverse is given by 1 by determinant of A into adjoint A. See formula sina P ko. Doi tardi nangi cofactor han holase. Here cofactor A11 is equal to 8 minus 6 plus 2 tare cofactor A12. 2 plus 1 is equal to 3, so there should be a minus sign. Minus tame ko. Since 0 plus 9 tare minus 9 tare. Then find cofactor A13. 1 plus 3 is equal to even number 4 tare ko. Plus sign nam laire. Plus sign du sima pase ka adi 0 minus 6 if hang neba. Then find cofactor A21. 2 plus 1 is equal to 3, so there should be minus sign. Find the determinant obtained by deleting second row and first column. Minus 1, 2, minus 2, and 4. Sileme ko the expander is minus 1 into 4 is minus 4. 2 into minus 2 is equal to minus 4. Minus plus cofactor A22. Minus 2 tare cofactor A23 minus 1 cofactor A31 is equal to minus 1. A32 is plus 3 and cofactor A33 is equal to 2. So raga ko na cofactor mayam ki value se putoe ko. Then write adjoint A. Adjoint A is the transpose of the cofactor matrix whose elements are capital A11, A12, A13, A21, A22, A23, A31, A32, and A33. See value mayam se le ko substitute by substituting the values of its cofactor. We have 2, 0, minus 1, minus 9, minus 2, 3, minus 6, minus 1, and 2. Hence, A inverse is given by the formula 1 by determinant of A into adjoint A. Here the value of determinant A is equal to minus 1. Then write adjoint A. Minus 1 into this matrix means all the elements of this matrix should be multiplied by minus 1. Minus 1 and multiplied toward the minus 2, 0, 1, 9, 9, minus 3, and the 6, minus 1, and minus 2. So, inverse of any square matrix formula amna putok pyare adogi formula do kay orani 1 by determinant of A into adjoint A. Next topic is applications of determinants and matrices. Determinants ka matrix ka gi anima ki applications ni ko. Dune sige applications si kaino solving system of linear equation. System of equations is solve the system of equation haidi kaino if two or more linear equations in one variable, two variable, or three variable coexist. Nangi variable system of linear equation haitardi linear equation se ani natraga ani dagi hena punna piramagadi si kai korani system of linear equations kawe ko. System of equations se variable ani yawe variable ahum yawe ko. Then sigi system of linear equations sida consistent oiba inconsistent oiba haina makal ani thongna khaida ka. First, let us define consistent system. A system of equations is said to be consistent if it has at least one solution. Nangi sumaina system of linear equation am piramaga xyz ki value se puthokpa ngamaba yamdrabada sigi solution ama leitaragadi khona kai korani consistent system kaweba. Solution haidi kamaina bu define tawgre. Solution hai tardi kaino values of the variable involved in the system of linear equation which satisfy equation number 1, equation number 2, and equation number 3. Sigi oina question 1, 2, 3 satisfy to x, y, z ki values se koina solution of the system of linear equations kauduneva. Sigi solution se amma khatang lebi more than one will be ko. Then the consistent system haidi kaino a system of equations is said to be consistent if it has at least one solution. Solution se yamdrabada kya legadaba amma legadaba more than one or so. Next, let's define inconsistent system. A system of equations is said to be inconsistent if its solution does not exist. Sigi equations is satisfied over x, y, z ki values amata laita taragadi sigi system of equations se kai kaurani inconsistent kaurani ko. Consistent haragana solution laiba, inconsistent haragana solution laitaba ko. Now let's solve the system of linear equations by using inverse of a matrix. Inverse of a matrix used taraga koina x, y, z ki value puthoktoini ko. First, consider the system of equations. Equations are a1x plus b1y plus c1z is equal to d1. This is the first equation. Second equation is a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. So mind taraga system of equation involving three variables. They are x, y, and z. We are going to find the values of x, y, z satisfying first equation, second equation, and the third equation. Let A is the matrix formed by the coefficient of x, y, z. A1, A2, and A3. A1, A2, A3 means coefficient of x. Nangna system of equation ang piram tardi coefficient of x first column the ini ko. B1, B2, B3. B1, B3 are coefficients of y. C1, C2, C3 are coefficient of z. So A is the coefficient. A is a matrix formed by the coefficient of x, y, and z. Then capital X. This capital X is the matrix formed by the variable x, y, and z. Then B. B is the matrix formed by the constant given in right hand side. Right hand side the gilawani d1, d2, d3 se sumai taraga koina A haiba mane, B haiba mane, x haiba mane matrix requa. So this system of equation can be expressed as kamine expressed where capital AX is equal to B. See mong the thumb requa. That is this matrix multiplied by this matrix equals to this matrix, then we get this system of equation. Habidi sigi matrix siga multiply tawragana koina system of equation se taba ngamgani bako. The condition kya lega? So the case ani thore ko. Case number 1, if A is a non-singular matrix ngasagi system of linear equation se kamain thambaya grass. The system of linear equation can be expressed as the matrix equation AX is equal to B hane thambaya reba. Dagi koina case number 1 habam case number 2 habam thor A. If A is a non-singular matrix, then its A inverse X is non-singular means determinant of A not equal to 0. Then A inverse X is the ranikwa. We have the matrix equation AX is equal to B. Then pre-multiplying both sides of this equation by A inverse. A inverse AX is equal to A inverse into B. Then this equation can be expressed as A inverse into AX, and this law is known as associative law kawigwa. A inverse X. A inverse into A will be equal to identity matrix by definition of inverse of A matrix. Inverse of A matrix ki definition gi matungina I ga manare, which is equal to A inverse into B. I into X is X. X is equal to A inverse into B. Say matrix equation amne. This matrix equation provides the unique solution for the given system of equations. Step P equation sina nangi so angasai system of linear equation gi solution, the unique solution pirakaniba. Case number 2, if A is singular matrix. A is singular matrix means if determinant of A is equal to 0 oragadi kona A inverse puthokpa ngamaroiba ko. In this case, we calculate H1 A multiplied by B. A join A the B na multiply to was calculate or any. Then there are two conditions in this case. If A join A multiply by matrix B not equal to O means zero matrix niko. A join A the B na multiply to was zero matrix ka manada taragadi, then the system does not exist. The solution of the system does not exist and the system of equations is inconsistent. H when A multiplied by matrix B not equal to zero matrix, then there is no solution for the system of linear equation, and this system of linear equations is said to be inconsistent. Inconsistent karani solution amta layraroiba. Second case number B dakwa, if H when A multiplied by B is equal to zero, then the system may be either consistent or inconsistent according as the system have either infinitely many solutions or no solutions. If A join A multiplied by B is equal to zero matrix, china zero matrix oibakana case ani thora ani ko inconsistent oibasui kai oibasui consistent oibasui consistent orakana na infinitely many solutions lerani nangi solution se more than one star ani ko aduga inconsistent oibya basu lebu inconsistent se karam kandu any solution am ta later kanda sumai taraga koina system of linear equations se solve to ngamiko kai sizinaraga by using inverse of A matrix. Now let's come to exercise 4.6. Question number exercise 4.6 na hai se kaino solve the system of linear equation. Na question nam khangale ko question number 11. The given system of linear equations are 2x plus y plus z is equal to 1. This is the first equation. X minus 2y minus z is equal to 3 by 2. This is the second equation. 3y minus 5z is equal to 9. This is the third equation. So main taraga nangi system of equations se equation ahum yaure duga variables so ahum yaure ko. So the system of equations can be expressed as capital AX is equal to B, where A is the matrix formed by the coefficient of x, y, and z. Write the coefficient of x in first column, coefficient of y in second column, and the coefficient of z in third column. And so the elements of the A are 2, 1, and in the third equation, x is absent. So it can be expressed as 0.x plus 3y minus 5z. Here the coefficient of x is equal to 0. When any variable absent the coefficient of 0 ireko. Then write the coefficient of y. Coefficient of y are 1, minus 2, and minus 1, minus 2, and 3. Then coefficient of z are 1, minus 1, and minus 5. So then write capital X. Capital X is the column matrix formed by the variable. Variable are x, y, and z. Then write this capital B. Capital B is the column matrix formed by the constant given in right hand side. Nanga sigi constant se left the layer magasu kaina right side the transpose togani ko aduna magi value se kai kai erani 1, 3 by 2, and 9. These are the values of this column matrix B. Then check the value of determinant A. Determinant A check toganeba. By expanding this determinant along first row 2 ireko. Find the determinant obtained by deleting first row and the first column. Minus 2 into minus 5, 10. 3 into minus 1, 3. Second element minus 1. First column first row ga second column ga 1 into minus 5 minus 5 minus 1 into 0 is 0, and the third is 1 tareka 1 into 3 3 minus 2 into 0 is 0. And by solving this equation we have determinant of A is equal to 34 not equal to 0. Determinant of A na 0 tadaba haibase kaino magi A inverse exist ko. Then this equation 1 becomes kay the sense torani capital X is equal to A inverse into B. See equation number 2 tharasiko. Then we need to find the value of kay value hot kani A inverse. By theorem number 4, A inverse is given by the formula. Kay formula na P gre 1 by determinant of A into adjoint A ni ko. And adjoint A putoke hai tardi kana gi value hot kani. We need to find the values of its cofactors. Cofactors are A11, A12, A13. First find the value of cofactor A11. A11. First find the determinant obtained by deleting first row and the first column. Stanga sa expand to 13 dareko. Then cofactor A12. 1 plus 2, 3 minus sign am thorakani cofactor gidiko. Then is the minus 5 plus 0, minus 5 minus minus plus. Then find cofactor A13. A13 se koina once I put 3 plus 0 se tagre ko 3 orani cofactor A21. cofactor A21 2 plus 1 is equal to 3 odd overgi minus sign am fange. Find the determinant obtained by deleting second row and the first column. Second row ka first column ka 1 1 3 and minus 5 minus 3 8 minus 8 to minus 2 the 8 are and cofactor A22 is minus 10, cofactor A23 minus 6, A31 is equal to 1, A32 is equal to 3, and value of A33 is equal to minus 5. So, maintaraga cofactor lo ito then write the formula of A inverse. A inverse is given by 1 by determinant of A into adjoint A. Value of determinant is 34 and this adjoint A is the transpose of the cofactor matrix. They are capital A11, A12, A13, A21, A22, A23, A31, A32, and A33. So, then substitute the values of its cofactors, and we have this matrix 13, 8, 1, 5, minus 10, 3, and the 3, minus 6, and 5. So, A inverse puthokpa ngame ko koina hojik puthokadabadi kaino xyz ki value hotkadabani na equation number 2 dam lakdoin. From equation number 2 dam yengasi from equation number 2, x is given by A inverse into B. X type of formula is A inverse into B in a period. Doitardi 1 by 34, 13, 8, 1 A inverse ki value ire and value of B. B is the column matrix formed by the constant. Constant are 1, 3 by 2 and 9 sitare ko. Sida kay pangani multiplication of two matrices palani ko. Find the sum of product of corresponding elements of first row, second row, and the third row of the A inverse should be multiplied by this matrix B. Multiply the 1 into 13, 13 plus 3 by 2 into 8. 8 divided by 2 is 4, and the 4 into 3 is 12. 1 into 9 is equal to plus 9. 1 into 5 is 5. 3 by 2 into minus 10. 10 divided by 2 is equal to minus 5. Minus 5 into 3 is minus 15. 3 into 9 is equal to 27. 3, 1 is equal to 3. Minus 6 into 3 by 2. 6 divided by 2 is equal to 3, and the 3 is minus 9. 9 into minus 5 is minus 45. Multiplication rule pale. Then find the sum of this expression. 1 by 34. First term 30. The first element is 34, second element 17, and the third element is minus 51. This matrix should be divided by kanana divide togani 34 na divide togani ka. See 34 na divide togase divide to. And see divide ragadi 34 divided by 34, 17 divided by 34, and minus 51 divided by 34. Koina left hand side x type of lagi ko. X is the column matrix formed by the variable x, y, z. Then for right hand side we have 1 by 2. 51 and 37 divided by 17 we have minus 3 by 2. By equating the corresponding matrices. From the matrix sum layer, matrix ani se mana ifang taragadi corresponding elements se mana doine. Therefore, x would be equal to 1, y is equal to 1 by 2, and z is equal to minus 3 by 2. These are the solutions for the system of linear equations. Nangi system of linear equation ki solution se asi value so ire x na 1 tare, y na 1 by 2 tare, z ki value na minus 3 by 2 tare ko. Mathang question number 5 se holasiko. If A is a matrix, A is a square matrix of order 3 nangon the element karapir, then find A inverse. First ko na kayan hot kani A inverse ko. Using A inverse solve the system of equations. Nang A inverse ki value holani using A inverse use toraga makagi system of equations ya mag solve tawdini ko. Question number 15. Question number 15. First write the elements of the matrix A, whose elements are 2, minus 3, 5, 3, 2, minus 4, and 1, 1, minus 2. Inverse puthokya itardi kaidawne, we need to find the value of determinant A. Determinant A. Expanding along first row, we have the value of determinant of A is equal to minus 1, not equal to 0 tareko. Therefore, A inverse exists. Determinant of A bu hek 0 etc. dardi magi inverse exists magi inverse puthokpa ngamani ba. And find cofactor of each element of the square matrix A. Here cofactor A110, A122, A13 is equal to 1, A21 is equal to -1, A22 is equal to -9, A23 is equal to -5, A32 is 23, A31 plus 2, A33 is equal to 13. Cofactor puthokpadi mamangdasu haigre cofactor se loin puthoe. Then now A inverse. A inverse ki formula is equal. A inverse is given by the formula 1 by determinant of A into adjoint A. 1 divided by -1. Since the value of determinant of A is equal to -1 and adjoint A is the transpose of the cofactor matrix whose elements are A11, A12, A13, A21, A22, A23, A31, A32, A33. ꯑꯩꯈꯣꯏꯅ ꯁꯤꯗ adjoint A ꯒꯤ formula 이래ꯀꯣ. ꯀꯩꯗꯧꯅꯤ ꯑꯗꯨꯒꯤ ꯃꯊꯪꯗ A inverse value ꯍꯥꯞꯆꯤꯜꯂꯁꯤ. 1 divided by -1 is equal to +1. 1ꯗ -1ꯅ divide ꯇꯧꯕꯁꯦ ꯀꯩ ꯐꯪꯉꯦ? -1 ꯐꯪꯉꯦꯀꯣ. By substituting its cofactor we have this matrix and this matrix should be multiplied by -1 neba. -1 oitaragadi all the elements of this matrix should be multiplied by -1. This change the sign of its element. Element naam se sign lo change taurani plus na minus na plus the taureko. Then second part the kai hai. It is given that system of equations period. First equation is 2x minus 3y plus 5z is equal to 11. Second equation is 3x plus 2y minus 4z is equal to -5. X plus y minus 2z is equal to -3. By using the value of A inverse, solve this system of equation. Duna ngasai koina hotkiba process to the chapmana na si solve tawdoiniko. The system of equations can be expressed as capital AX is equal to B. Write equation number 2 where capital A is the matrix formed by the coefficient of X 2, 3 and 1. Coefficient of Y -3 plus 2 and plus 1. Coefficient of Z 5 -4 and -2. Then write capital X. Capital X is the column matrix formed by the variable X, Y and Z involved in the given system of equation. Then write capital B. Capital B is the matrix formed by the constant or real number given in right hand side. Elements are 5, 11, -5 and -3. So the piriba number singse asina form tawbu oigadaba. Since A inverse X is asai A inverse puthokre ko sigi A gi value ga sigi A gi value ga mamangi A gi value duga chap manabanina A inverse exists to tawre and we have the value of A inverse in equation 1. Equation 1 danang A inverse ki value su phange ko. Then equation number 2 becomes this matrix equation AX is equal to becomes capital X is equal to A inverse into B. Substitute the value of A inverse from equation number 1, then write the value of this matrix B. Find the product of these two matrices. Matrix ani sigi product hotsika product hole 11 -5 and -3. And find the sum of product of corresponding element. 11 into 0, 0, 11 into -2, -22, 11 into -1 is equal to -11 plus -5 into 1 -5 -3 into -2 6 tarekwa -5 into 9 -49 -3 into -23 minus plus 69 -5 into 5 -25 -3 into -13 plus 39 sumai taraga koina product loin pale ko duga marakta plus sign thame sigi value holise -5 plus 6 1 -22 -45 is -69 -67 chumain thamne ko ani se punba se -67 ni -11 -25 is -36. This capital X say XYZ na represent the 1 69 -67 is plus 2 39 -36 is plus 3. By equating corresponding elements we have value of X is equal to 1, value of Y is equal to 2 and value of Z is equal to 3. Akoina sumain tawraga XYZ ki value hotpa ngameko. For today let's end here.